There's been a lot of news in the AI assistant space this week. American social media is all over Mark Rober's attempt to make the obsolete Tesla autopilot look bad with a like a Wile E. Coyote trap.
Oh boy, all right.
And some camera trickery, but then Chinese social media is fawning over how good Tesla's self-driving technology is. Which is actually really impressive when you consider that they trained it using internet dash cam footage of China's roads instead of real sensor data. However, I, as you probably know, am less interested in self-driving cars and AI-powered personal assistants. I am more interested in an AI combat buddy. So in this video, we will build out the specs for the most useful battlefield assistant possible. And spoiler alert, it looks like this. Okay, so robotic combat companions and starfighter co-pilots are not a new idea. They're actually a sci-fi staple. Very useful friends that you should have for your Star Wars or your other wars. Robots that can fix your ship or watch your back or smuggle your weapons. I'm just talking about R2-D2 at this point. Robot buddies are so common in sci-fi, it's more surprising when they don't show up.
Yeah, you can use it to find your way back into the ship after I blow you out the airlock.
What's your humor setting, Cars?
That's 100%.
Let's bring it on down to 75, please.
Welcome to the Satellite of Love. I've asked Joel if he'd raise the level on my sarcasm sequencer.
However, as much as I love physical robots in movies and reality, for this video, I'm thinking more about the purely software-based AI tools that help with combat advice, tactical insight, and situational awareness, like Iron Man's Jarvis.
Jarvis? You ever hear the tale of Jonah?
I wouldn't consider him a role model.
Actually, that's still maybe a little too sarcastic for me. So let's think about the Cortana combat AI that was built into Master Chief's helmet, giving him heads-up display and all sorts of information from different sensors. Although, to be honest, I'm actually more familiar with the red versus blue lore than the real Halo lore.
AI. What's the A stand for?
Artificial.
What's the
Intelligence.
Oh, what was the A again?
Let's move on.
But this idea is really obvious. You stick a powerful AI in your helmet to be an extra pair of eyes and some extra brains and to know a bunch of stuff that the lone warrior or player needs to know or hear about to finish the level.
How long to transfer?
About 45 seconds. That should give you enough time to deal with the 3 security personnel who are about to come through the door. Which door? There's only one door. They just set a breaching charge, by the way. What?
These things are also great for exposition. Now, we have AI assistants today, which are a little bit less useful in combat, like these Meta Ray-Bans here. Because they have a camera, they can actually see what I see. They have microphones so that they can hear what I hear. We can even have a conversation, sort of. But apart from a few party tricks and looking stuff up on the internet, they still don't do very much. And the reason for this is mostly that they are dependent on the cloud. And then another reason is they don't have very good sources of real-time data. But ultimately, they're just not built to do any combat-oriented tasks. So instead of working forwards from what the existing tools can do, let's work backwards from the specific problems that we want to solve. Let's design a genuinely useful combat AI, something that is possible with today's technology. And we'll start by building out our base level requirements. So number one, it has to be local computing or edge computing. That means no server, no cloud, no dependencies on the internet, no two-way communication for other people to sniff out. That is a hard requirement. This thing is going to have to work all by itself. And then the second requirement is, what does it do? Well, I want greater spatial awareness. I want information about stuff that is going on around me. One of the greatest force multipliers that I can have outside of more guys is more intelligence on my surroundings. So I would like to get some alerts on things going on around me that I am otherwise not noticing. Now at the moment, my eyes and ears work pretty good, and processing huge amounts of video and audio information so that AI can somehow glean insights from it is very time consuming, or if you're doing it locally, it's very power consuming, like massive amounts of computer power are required, and it generally requires tons of battery power. So this is not a great thing to carry around. However, I don't have any biological sensors that detect electromagnetic radiation. I need digital sensors to pick up some of the radio signals that are around me, and then the data that is being collected by a software-defined radio, say, well, that's already clean digital data that's ready to pipe straight into a computer to be analyzed. So this right here is the obvious sweet spot for us to start. This is going to be the best place for an AI assistant to actually assist. Now in last week's video, we talked about software-defined radio, powerful digital tools that can see the entire RF spectrum all the way from HF radio up to gigahertz, or maybe we did it backwards. I can never remember which way we actually built the graphics, but you should watch that video for some more insight into practical tools that you can use today, or that you can buy today and are very affordable. Things like this RTL SDR, which is 40 bucks, and then all the way up to this H2 Portapack with a hack RF inside. Tons of possibilities, and we barely scratched the surface of what SDRs can do in that video. We could see more of the RF spectrum if we spent more than a few $100. We could analyze and accomplish a lot more. This RTL SDR is a ridiculously basic device, and it's got some weaknesses. It's easily oversaturated by strong signals. The hack RF is also sensitive. You can burn it out. You can actually burn it out with its own transmitter, weak as it is. So there are professional tools that we could buy in the space, industrial, commercial SDRs. The one that I've been looking at recently is the SignalHound SM200C, which gives you 20 gigahertz of radio bandwidth and over 10 gigabits per second of data bandwidth, so that you can really see everything all at once. Unfortunately, it is $20,000, so it's not exactly in my cart at the moment. I would say that the sweet spot for the radio that we want to put into this device, probably about $1,000. In that range, we could get something like the Lime SDR XTRX or the Signal SDR Pro. Both are available to order on Crowd Supply. I don't think they ship immediately, but I kind of built this thing around the Signal SDR Pro. Multiple antenna inputs, better processing power, and a capability to see a lot more of the bandwidth, both in radio terms and in data terms. And that processing power and sample speed, this is important. This gives us more options so that when we have our multiple inputs here, we can actually look at multiple bands at the same time. But honestly, we really don't need a whole lot more capability than we already have in these things. We just need a little bit more to get exponentially better results on our insights. So I've tried to design this device in such a way that it is kind of the sweet spot in capabilities, some future capabilities that nobody has really brought to the market quite yet, but also very doable with stuff that is currently on the shelf or just around the corner, hopefully shipping in the next couple of months. So the main thing that you see here is a very simple body. I wanted to make this thing really easy to build as well. So the idea is that this would be an aluminum extrusion that gives us some strength and has a built-in heat sink. And it's got some space for 18650 batteries. We hold 4 of them, so that is a fair amount of power to keep this thing running. We probably also want to throw some dedicated radios in there in addition to the SDR. A GPS receiver is tiny and takes up almost no room. We should probably also have a dedicated Bluetooth transmitter, because when you're doing really specific jobs, radios that are built to do specific jobs often perform better than the SDRs that can do everything, and you got to write code for it all. So once we put these dedicated things in here, we also want some processing power. Maybe we want an ESP32, which is tiny and uses almost no power, which means this thing could run for a very long time on our 4 batteries. But we actually need a little bit more power than the ESP31, and most SDR boards actually have some processing power built in, and oftentimes some other things as well. Like the Hack RF board that is inside the Portapack here has a field programmable gate array. Yes, we'll still talk about those in the future. It has an SDR card, it has USB port, it has a bunch of things that allow you to use it in a bunch of different ways. But flashing a simple operating system onto the field programmable gate array lets it run by itself, and most of the tools that we would consider putting in here have this capability as well. It's possible that we could have a really self-contained device that is extremely power efficient and still powerful. But one of the things that you will notice about this device as you look at it is no screen. There's no way to actually see what is going on in the RF space. And this is kind of maybe a controversial take for me. To be perfectly honest, for most of the things that I want to accomplish, I don't actually need to see the RF space. I mean, I enjoy seeing it. There's some super cool new apps that visualize the spectrum amazingly well. It's incredibly fun to look at that stuff, and it provides a huge amount of awareness and knowledge and information for a knowledgeable guy that knows what specific signals look like. But for pulling out insights and intel for someone who's less experienced like me, I actually want this thing to do all of that work. Essentially, since I can't see into the RF spectrum with my actual eyes, I don't want to waste my time trying to interpret stuff. I want a tool that tells me what's going on, and honestly don't want to look at it with my eyes. I don't want to constantly be using my brain to do the interpretation. I just want to hear signals. I want to hear alerts. I want to hear notifications. And probably the best way to do this is Bluetooth earbuds. Just send me an audio notification that tells me what's going on. So now that I have my Bluetooth earbuds in and I'm connected to this device, I can hear alerts from this thing. So we should now at this point dive into exactly what it is that it does. What are its main core functions that I want it to do and to tell me about? Well, the first one is jammer detection. I mentioned jammers in the last video. Signal jammers being heavily used by criminal elements, whether it's gangs in South Africa, whether it's certain unsavory elements in the Middle East. We're starting to see cartel activity here where people are doing things with ill intent, whether they are jamming your cell phone so that you can't call 911, whether they're jamming your GPS so that you can't find your way out of a place. Also, you know, Ring cameras and other cheap cloud security cameras generally are wireless. They connect using Wi-Fi, so it's really easy to use a jammer to turn off your security cameras that way. But fortunately, jammers are really easy to detect. It's just high levels of noise, very loud signal noise across multiple bands. And you can just set a pretty simple trigger. If contiguous signals are wider than like 25 hertz or 25 kilohertz or 25 megahertz, you can set them yourself, and then higher than a certain dB level, just trigger the jammer alarm and tell me in my ear,
GPS jammer detected.
Now, if the jammer is close enough and strong enough, it may interfere with the Bluetooth connection here. But if this thing is close to me, and I built this thing in such a way that it is a shape that goes really well on different parts of me, like on the belt or on the back of a helmet or things like that. It goes really well on the strap of a bag or inside of a bag. If this is close enough to me and the jammer is not like right there, I should be able to determine this. Also, if they're jamming cell phone data, so I can't call 911, and not Wi-Fi, I'm still going to have my Bluetooth connection because that happens over 2.4 gigahertz. But yeah, the wireless link is kind of a weakness on that jamming front. But if I suddenly hear this alert,
cell phone jammer activated,
I now know that I should be on the lookout, and I am still able to hear alerts while I look around with my eyes. The other really obvious one that everyone is going to want is drone detectors, which, depending on where you're using this and what kind of drones you want to detect, is either really easy or kind of difficult. First of all, especially here in the States, a lot of drones have a really identifiable signal. A lot of commercial drones actually have a little remote ID transponder that broadcasts, and so detecting that is a piece of cake. Drones that use Wi-Fi are going to show up as regular Wi-Fi, but drones that have a specific protocol can be picked out pretty easily. We can even make a pretty educated guess as to the make and model of the drone based on some protocol information that is not particularly hard to sniff. Now, in other parts of the world, in battlefields, oftentimes it is an analog video signal, and those also stand out. Now, it could be a security camera that has an analog transmitter. Those also exist in other parts of the world in pretty high numbers, but one of the things that once we can do with this radio, if we have the little GPS receiver in there, is it can know that I'm not moving. So if the signal is fluctuating in strength, it's moving, and we can make an educated guess that it's not a stationary security camera. It is probably a drone, and then I get an alert.
DJI drone in area.
Now, there's some other ways that we could try to identify drone-specific signals. Maybe they have Doppler shift. Maybe they have other characteristics that we could figure out and be on a specific lookout for. But now we're getting into a more complicated signal analysis that I will talk about a little bit later. Let's move on to our next really useful task for this guy, and that is identifying other flying devices. Low-flying aircraft generally are supposed to, required by FAA, to have ADS-B transponders. So the ID of the aircraft, its N number, its altitude, its heading, etc. These are things that are supposed to be transmitted by any aircraft. And I just want to know about anything that's happening at low altitude. I don't need to see every single aircraft that is in my current airspace. I just want to know if there's something nearby, like air evac happening near me that's going to affect traffic, or there's an emergency that I should be aware of. Police helicopters flying very low and slow directly over me. I just kind of want to know that. Maybe it's because, like I said, emergency awareness, or maybe I just want to, go outside and look at airplanes and helicopters because they're cool. Now, it's also very cool to see this stuff on a map. There are some really cool three-dimensional plane tracking apps that give you tons of data on what's actually happening in the airspace, but if I'm out and about and doing stuff, it's much faster if I just hear altitude and distance from me, and I can just do that over audio.
Aircraft at 5,000 feet due west.
Or, since these are really small text notifications, maybe I want that to come to my smartwatch. Really easy to feel it buzz, look down, and know that there is an air evac helicopter at under 5,000 feet. Really simple to grab that. Or maybe that is a good use for the Even Reality's G1 glasses. Little identification pops up right here, and it tells me about some stuff that's going on. Really small text notifications of what's going on without distracting me from the stuff that I'm actually doing, or, based on an emergency situation, needing to do. And then, speaking of emergency situations, this thing could also pick up on the NOAA radio alerts. Oftentimes, there are emergency broadcasts that tell you about incoming storm warnings or tornado watches, stuff like that. And you probably have, you definitely should have, an analog radio in your house that picks up on these alerts, especially, we're going into storm season. It's generally a good idea to have. There's nothing that stops this radio from hearing those things and alerting me and playing that back over the earbuds.
Doppler radar shows this tornado moving east-northeast at 50 miles per hour.
Most of these alerts that we have nowadays are things that you expect to get on your phone. There's an assumption that if you want to see the weather around you, you want to see the traffic around you, you want to see any internet enabled data, you're going to just grab that with your phone. You're going to have this two-way digital internet communication with the cloud. So you are probably relying on your phone to give you weather updates and weather alerts. But that assumes that the internet is working, your cell towers are working, and so forth. Having an analog radio station that picks up on these things is kind of a big deal. And honestly, I would love to get back to a little bit more of a robust system. Some of the analog radio transmission stuff is way easier to keep running in emergencies, and it's much more decentralized in general. I mean, the fact that if all of us here at T-Rex, who are in the same zip code, want weather data, all of our phones are going to be asking servers for specific weather data that is all the same. It's kind of inefficient, as well as being, well, a privacy and security nightmare. Far better if we set up a single little radio broadcaster that just multi-point broadcast upcoming weather data, maybe over LoRa, maybe analog, something like that. And then if you're in the range of the transmitter, you are in the right area to get that specific weather data. And if you're not, then you aren't. It's simple, it's really, really robust. I wish we'd kind of get back to that mentality of some of the information that we put out there. Less dependence on servers and the internet. The other thing that I really want this to do is listen to public safety radio. When I was a volunteer firefighter, I had a radio that I carried with me all the time to listen to our specific frequency. And I had it programmed with other frequencies because it could dual watch to figure out what is going on in my county. Now, the rescue squad had unencrypted radios. Our law enforcement traffic these days generally is going to be encrypted in basically every jurisdiction. And this thing should be able to pick up on that, even though it can't decrypt that traffic yet. It can certainly identify the codec that is being used and the band where it is being transmitted. So being able to pick up on these alerts and let me know that there is a
police calls nearby,
higher than average call volume in our area, for example. I mean, that is a thing that I want to know. Even though I'm not on the rescue squad anymore, this would be information that would be actionable intel for me. So it's really just a matter of setting limits and triggers. If there's more transmission volume than normal, or if it is a higher power, like a higher decibel than a threshold I've set, then it's in my part of the county, or it's closer to my house or where I am. These are things that I would just like to know, and it takes not very much sophistication to get that kind of data.
multiple calls from dispatch.
And then, of course, we should probably talk about regular ham radio, public radio, GMRS radio, FRS radio call volume. That stuff is all unencrypted, just regular FM stuff, super easy to demodulate. So technically with this thing, we could listen to all the radio basically all the time, just have tons of audio just coming in through the Bluetooth. But obviously there's a little bit of a privacy concern there. Also, it would be super distracting. So I'd rather get, just an alert that there's a lot of FRS radio traffic on this channel in this area, or there's something going on that is really close. Then I pull out my actual radio and I can listen in or talk to folks. So just an awareness of what's happening is probably good. Now, I might want to change that as we go different places and we do different stuff. I may want to change the alerts and the specific notification that I would like to get. So using the Bluetooth radio that is in here, we probably do need an app. Probably the easiest way to control this thing is to have a really simple app that allows us to have the control panel for this thing and set some of that stuff up. And if you are a ham radio guy, this could be an incredibly handy tool. Like I could set this thing to always listen to certain channels where I know stuff is happening. We could even intercept is the wrong word. We could receive, legally, because receiving is always legal, text messages like APRS messages, VARA messages, JSA call messages. We could grab those things, and then this thing has the computing power to read me some of those text messages using text-to-speech just right into my earpiece. And maybe I would set it up to be only messages from certain call signs. So anything that Tech Prepper is doing on the APRS network or the JSA call network, I can hear when he's active and some of the stuff that he is doing. So yeah, if you have a little bit of control over this device, all kinds of stuff gets to be possible.
KT7RUN is online.
And then, because everybody loves LoRa, maybe we stick a LoRa radio in there. They can be incredibly tiny devices. So yeah, maybe we stick a dedicated LoRa device in here. Maybe we just have a little 10 lines of code that look for specific LoRa communications. Very easy to identify, and I get an alert that there's LoRa traffic, and I turn on my LoRa radio or get into an active mesh-tastic network. So yeah, it all depends on how you'd want to use this thing. If you had some control over it, it could be an incredibly flexible device. Now, I'm going to mention another thing which is perhaps a little bit more controversial. I'd also love to use this thing as an IMSI sniffer. This means that I would be listening to cell phone packets. Now when I say listening to, I don't mean decoding and intercepting cell phone calls. I would just be seeing the data that goes back and forth between a cell phone and a cell phone tower. This is probably only useful in a rural area. If you're in a very rural area, having a new Wi-Fi device show up is probably an interesting data point. All of a sudden, there's a new Wi-Fi device in your area where normally you don't have any neighbors. That's kind of interesting. And cell phone is even more interesting. The cell phone data is probably a better alert that there are new people in your area of operations.
New 4G device in range.
It's really easy to pick up Wi-Fi devices in an area. They have MAC addresses, but phone modems have IMSI numbers and IMEI numbers. So I'm not advocating decrypting the traffic. I'm not advocating, there's no transmitters in this thing, that we interfere with the traffic. There's going to be no eavesdropping, nothing illegal. Just detecting the packets and looking at the header to see if there is a new phone modem on my property. Like, that would be an incredibly useful thing for me where I am right now. Could come in awfully handy. And then if we have that capability, there's another useful tool. This would be more valuable inside of an urban operation. This thing could easily be a Stingray detector. Now, a Stingray is a device that simulates a cell phone tower, and they're generally used by law enforcement, but they're starting to be used by other let's say unsavory elements. The reason that you would simulate a cell tower is so that you could intercept the data from here, insert your fake cell phone tower between me and the real tower. A Stingray can actually do the eavesdropping and the data collection from the device. Now, there are certain things that make a Stingray act a little bit different from a cell phone tower, and my phone isn't sophisticated enough to figure that out, but this thing might be. I would love to get an alert if there is a cell tower operating in my area that doesn't act like an actual cell tower. That would be a nice little heads up. Maybe it's not people who are specifically looking to intercept my traffic, but it's the kind of operation in my town that I would just, appreciate a heads up. Now, that is just a few top of my head ideas on what we could do with a device like this that goes pretty much anywhere on your kit and has decent battery life. Now, I know that at the beginning of the video I promised you a sophisticated, futuristic, classic sci-fi BattleBot co-pilot AI combat assistant with some sassy sarcasm, but this doesn't actually do that. In fact, the cool part about this device is that none of these features that I have just mentioned actually need AI at all. They are just really basic triggers. If this frequency at this strength, then a notification. Read it out loud over the Bluetooth or send it straight to the glasses. Really simple stuff.
Who you calling simple, pal?
Really simple rules that you set in a really simple app, which means very low power requirements, and it doesn't run warm, it stays small and light, and it lasts for a long time. And this prototype here is very simple. I would really like for us to stick with stuff that is simple for some of these jobs. There is a tendency in the electronics world to not do simple, but to just put everything essentially on an Android device. If you remember in the SDR video, I ran some SDR software on this device. I connected it to the RTL SDR with a dock and did a whole bunch of stuff. To be perfectly honest, that was a pain. And it was a pain for a lot of different reasons. I had to download some new drivers. Some of the software had been updated and it didn't work with this device anymore. There was a bunch of stuff that I had to kind of tinker with to keep it up and running. Meanwhile, an all-in-one device like the PortaPack H2, it just worked. I pulled it out of the box, I turned it on, and it was running. It has its own operating system. It lacks power, but as soon as I hit the button, it turns on, immediately boots up, and yeah, it doesn't have the infinite capabilities and scalabilities and color animations and all sorts of fancy stuff that Android does, but it just plain works. And it's an all-in-one device that does a dedicated job. I prefer it to running every single thing through my phone. And that is something that I would love for us to stick to when it comes to building devices like this. Oh, by the way, there's a new version of the PortaPack H2 called the H4M. It's got some significant improvements. So that's the one you should be looking for if you are in the market. That being said, if we wanted to add more AI capabilities to this device, there are some things that we can get out of it, and there are some pretty small AI-capable devices. NVIDIA makes Jetson GPUs that are specifically for this type of application. They're extremely small. They're pretty power efficient. We could run a small LLM trained on radio data on one of those, and we could be a lot more sophisticated. That would give this the capability to make some more, I don't know, educated guesses, specifically about the drone detection, some more complicated logic around some of the Doppler stuff. It would learn about the local traffic in my area, and it would be able to pick out anomalies a little bit better. If we had storage space on this thing, we could have large databases of, say, all the aircraft in the world, because there's actually less than 500,000 of them. We could have databases of a huge amount of the different frequencies that are used by different departments or different people. We could have a database of just samples of all the different radio protocols. And so it would be much smarter about identifying stuff and making assumptions about why it might be seen in your area. And then, you know, if it's an LLM, you can talk to it. You can tell it to do stuff and apply some of the filters just verbally. Sarcasm setting, you know, that's up to the actual developers.
Hey.
But when you apply powerful software, even to really basic hardware, there are all kinds of possibilities that open up. So this thing could be a fascinating platform where we develop a lot of new, previously unforeseen ideas. I mean, this RTL SDR, I think I said in the last video, is about 15 years old, the original chipset. These things have been used by hobbyists for over 10 years, and there's still people coming up with all sorts of fascinating new applications with these things. It is so basic, it doesn't even get up into Wi-Fi range. This USB 2 interface is ridiculously slow, but people are still making awesome stuff out of these things, like the SDR Kraken.
Kraken!
There are 5 of these RTL SDRs connected together, and they're synchronized with a clock, and if you space those out equidistantly, their antennas can detect different signals and determine exactly where the origin of those signals is. Now, there's a lot of ways to do direction finding. Ham radio guys do a thing called fox hunting. The best way is to get a directional antenna and look at the signal strength and look around and narrow it down to a direction. Then go there, grab another azimuth and follow it, etc. But if you have multiple radios and multiple antennas and you have really good clock sync and you have a little bit of processing power, you can determine time offsets and direction that way. So the Kraken has a very cool piece of software that runs on an Android phone that just shows you the directions of signals as you drive around, helps you find transmitting stations. Very, very fancy stuff. There's a guy, I'm going to get his name wrong, but we'll link to the video, who has built essentially a radio camera using these little tiny ESP32s that are the CPU and the Wi-Fi radio built in. By building an array of these, he's actually able to see where signals are in the frame of a video. It's a really fascinating stuff. Then there are other researchers that have done some things where just using the Wi-Fi that is already in this building combined with some AI, some good antennas, they've built tools that are really good at guessing how many people are in specific rooms and where they are in the rooms, kind of like a passive three-dimensional radar system. So if we had AI capability, some good radios in a device that was a little bit more expensive than this, maybe we would discover a whole bunch of fascinating new use cases, and it would become more of like that actual combat assistant. And believe it or not, there's actually a company that has essentially the device that I have just described, and it's Anduril. The device is called Pulsar. It can receive, it can also transmit, it can gather data, it can analyze it, it can find targets, it can jam targets, it can do all kinds of stuff. And I would sort of like one, but it is very expensive. It's even more expensive than the commercial industrial SDRs that I mentioned at the beginning of the video. And in some ways, price doesn't matter because the FCC would not let Anduril sell this device. They won't let me buy it. Probably the FAA, State Department, Commerce Department, FDA too, maybe. There's probably a lot of agencies that will not let Anduril sell this device because of reasons. But this sort of begs the question, what about something that doesn't break FCC regs? Would something like this sell? I'm assuming that in the comments there's already a bunch of people asking where they can buy this. And that number of people might not be enough to justify building it. But I think this is something that becomes more important as time goes on. As we continue to educate people about the capabilities of these devices, the usefulness, the practicality of them, I think that we could develop a market for something like this. I think a lot of people would want something that is this powerful and yet this basic, a standalone device with basic functionality that does one thing and does it well, and provides much greater knowledge and awareness for the serious citizen. I actually think that there is a need to develop stuff like this, and people beginning to value this kind of stuff, that's just the beginning. So yeah, this looks really dorky, but the existing counterweight is just rocks. So yeah, definitely an improvement.